Okay, hi everyone. So today we'll be starting off our chemistry series, and today we will be looking at balancing equations, right? Okay, so here I've outlined 3 steps to follow when balancing chemical equations. So the first one is count the number of atoms per element that are found on the reactant and the product side, right? Second one is use coefficients to balance the number of atoms of each element in the chemical equation. And the last one is balance oxygens and hydrogens last. Okay, so when balancing equations, I like to basically draw a vertical line underneath the arrow. And basically, this vertical line helps to separate the reactants from the products. Okay, so let's look at step one. Step one is count the number of atoms per element, right? So how many elements do we have here? We have 2 elements. We have one iron. We have 2 chlorines, right? 2 chlorines, and that's on the reactant side. Let's look at the product side. Let me actually just label this. These are the products, and these are the reactants here. There we go. So products, we have one iron. We have 3 chlorines. Okay. Now, now, we have one iron that's balanced. However, see how we have 2 chlorines and 3 chlorines. We have to balance this. One way we can do this is basically by multiplying this bit by 2 and this bit by 3. And what do we have now? We have 6 here and we have 6 here. Okay, now let me just erase this and write down my coefficients, right? So we said we multiplied by 2, we multiplied by 3. However, note that when I multiplied this by 2, I have also changed my iron count, right? So instead of having one iron, I now have 2, right? So we have 2 iron in total. We have 6 chlorine, but we have one iron here. So what we can do, we can multiply this bit by 2 as well to give us 2 in total. So then you write your 2 there, and this is balanced. Now, I forgot to include this in the in the steps to follow when balancing equations. But I think it's really important to basically always verify that you have correctly balanced your equations. And how can you do this? Basically, repeat step one. Repeat step one. So again, there's my vertical line. There's my iron there. I have 2 iron, chlorine. We have 2, right? 2 chlorine. 2 times 3 is 6. So we have 6 here. Chlorine, iron. We have 2 iron. 3 chlorine, 2 times 3 is 6. Cl6. There we go. 2 iron, 6 chlorine, 6 chlorine. That's balanced. I can't spell. That's balanced. There we go. Now let's look at the second chemical equation. You can pause this video and try balancing this. Okay, so unlike the first equation, this time we have hydrogens and oxygens in our chemical equation. So we will actually have to do step 3, right? This step. Okay, let's look at what we have. So we have 3 carbons, right? 3 carbons, 8 hydrogens, and 2 oxygens. And this is on the reaction side. Let's look at the product side. At the product side, we have 1 carbon, right? Just one. We have 2 hydrogens, so we have a 2 here. Okay, so we have a couple number of oxygens, but on different compounds. So we have 1 oxygen, and we have 2 oxygens. So 1 plus 2 is 3. So we have 3 oxygens in total. So I'm just gonna erase this and write 3. There we go. Okay, so let's balance this. So first step is use coefficients to balance the number of atoms. How do we do that? We can multiply this carbon here by 3 such that we have 3 in total. So now we can add our 3 up here. Okay, but also note that although I've balanced my carbons now, I've actually changed the number of oxygens I have. So instead of having 3 oxygens on the product side and now have 7, right? Because it's 3 times 2 is 6. 3 times 2 is 6 plus this 1 oxygen there, giving us 7. So we have 7 oxygens. Okay. Now we can balance hydrogen. Let's balance hydrogen. So we have 2 here with 8 here. That's simple. We can multiply this 2 by 4. That gives us how much? That gives us 8, right? 2 times 2 is 4. So let's, 2 times 4 is 8. So we have a 4 there. There we go. However, also note that basically what I've done is I've also changed the total oxygen count, right? Because what do I have? I have 4 oxygens, right? So, and I have 4 oxygens here, and I have 6 oxygens, right? Because it's 3 times 2, 6. That gives us 10 oxygens in total. So let me write down the 10. Okay, so my carbons are balanced, my hydrogens are balanced. It's only my oxygens that are not balanced right now. Okay, what can we do to balance them? We can multiply this oxygen here by 5, right? We can multiply that oxygen by 5 to give us 10. And we have 10, and then we can add our 5 there, and that's balanced, right? Balance, balance, balance. Okay. What we can do then, we can move on to verify that we have correctly balanced our chemical equation. So let's see what we have. So we have 3 carbons, right? 3, 8 hydrogens, 8, and 10 oxygens, right? Because it's 5 times 2, so 10 oxygens. That's balanced. Let's look at the product side. Okay, the product side we have 3 carbons, right? Because it's 3 times 1, so we have 3. We have 4 times 2 is 8, so we have 8 hydrogens. We have 4 oxygens plus, well, let me write it down. So we have 4 oxygens, right? So there we go. So it's 4 times 1, that's 4. And then we have 3 times 2, right? Which is 6. So we have 10 oxygens in total. That's balanced, that's balanced, that's balanced. Now note that I've basically written no number here. Do you see how I've basically left this dash blank here? That's because in chemistry, when there's no number before a compound or before an element, that usually tells us that there's 1. Okay, we could add a 1 here, but that's quite redundant. Okay, leaving it blank still sends the same message. So this is balanced. Okay, let's look at another example. Okay, so this is a bit interesting now because instead of having my atoms with no brackets, I've actually introduced brackets now. And let's try and understand what this means. Okay, see how I have this sulfur here. Well, actually, let's look at our reactant side first. Let's look at the reactants and we'll get to the products later. Let's look at the reactants first. Okay, so we have 1 iron, right? 1 iron. We have 3 bromines. 3 bromines. We have 2 hydrogens, 1 sulfur, and 4 oxygens on the reactant side. Okay, now let's look at the product side. What I was trying to say earlier with this bit here is that see how we have these elements in brackets. What this basically tells us is that, see how we have these elements in brackets and then a little subscript outside the bracket. What this basically tells us is that we will multiply the number of atoms per element in this bracket by this subscript here. Okay, what do I mean? Okay, see how we have 1 sulfur here. We'll multiply this 1 sulfur by this 3 here. So instead of just writing 1 sulfur, I have 3 sulfurs. Okay, that makes sense, right? Let's look at the oxygens. Instead of having just 4 oxygens, I will multiply it by these 3 to give us 12 oxygens in total. Okay, so we have 12 oxygens on the product side. Okay, then what else do I have? Now I can go on and balance everything else. So we're not balance, but write down how much I have. So I have 2 ions, 1 bromine, and 1 hydrogen. Okay, that's good. Okay, so let's start balancing our iron first, right? Okay, so we have 2 here, 1 here. Simple. We can just multiply this by 2, right? So multiply this by 2 such that we have 2 ions in total, right? So I can add my 2 there, right? So 2 times 1, we have 2. Our ions are balanced. However, note that by introducing these 2 here, I've also changed my bromine count on my reactant side. So instead of having 3, I now have 6, right? Because it's 2 times 3 is 6. So we have 6 bromines. Okay. We have 1 bromine there still. Okay. We can just go on and balance our bromines, right? So if we have 6 bromines here, sorry, if we have 1 bromine here and 6 bromines here, we can basically multiply this by 6 to give us 6 in total. So we add a 6 here. However, also note that by introducing this 6 here, I've also changed the hydrogen count, right? So instead of having 1 hydrogen on the product side, I now have 6, right? So multiply by 6, and now we have 6, right? So we have 6 bromine, 6 hydrogens. Okay, let's see what else do we have. We can go on and balance our sulfur, right? Because see how we have S3, S1. Let's balance that out. We can multiply this sulfur here by 3, then that gives us 3 sulfurs. Okay, so we have 3 here. But again, see how there's other elements in this compound. So when I put a 3 here, I'm not just multiplying the total number of sulfurs by 3. I'm also multiplying the hydrogens by 3, multiplying the oxygens by 3 as well. So let's see how that changes things. Okay, so instead of having 2 sulfurs as I did earlier, I now have 3 times 2 sulfur. Instead of having 2 hydrogens, instead of having 2 hydrogens as I did earlier, I now have 3 times 2, 6 hydrogens in total. Sorry for the confusion there. So 3 times 2 hydrogens giving us 6. Let's look at the oxygen. Instead of having 4 oxygens, I now have 3 times 4, which is now 12. 12 oxygens, right? 12 oxygens. Okay, let's see. This looks balanced, right? We have 2 ions, we have 6 bromines, we have 1 hydrogen, 3 sulfurs, 12 oxygens. Again, as usual, let's verify that we've actually correctly balanced this chemical equation. Ooh, let's erase this. Okay, so again, 2 iron, 6 bromine, because it's 2 times 3 6 bromine. We have 6 sulfur, 6 hydrogen, because it's 3 times 2, so 6 hydrogen here. We have 3 sulfur, because it's 3 and 1 sulfur. Let me remove, there we go, because it's 3 times 1 sulfur, so we have 3 sulfur there. And then we have 3 times 4, which is 12, so we have 12 oxygens. Now let's look at the product side. At the product side, we only see how we have no number here. That basically tells us that there's a 1. There's a 1 there, okay? We can include it. Most people choose not to. So we have 2 iron. We have, okay, see again, we have 1 sulfur, 1 times 3. So we have 3 sulfurs, okay? We have 4 oxygens here, but we also have a 3 outside the brackets. 4 times 3 is 12. So we have 12 oxygens. We can now look at the remaining elements. So we have 6 hydrogen, right? Because it's 6 times 1, so 6 hydrogen. And 6 times 1 bromine, 6 bromines. There we go, 2 iron, 6 bromines, 6 hydrogens, 3 sulfurs, and 12 oxygens. That's balanced.